We're going to spend some time talking about the CRUD pattern in Hapi. We've talked about the CRUD pattern in isolation in the context of objection and connects, and we've talked about how Hapi works and Hapi's route handlers and the like, but we haven't really talked about how to use the two together. We've used a couple of the items in the CRUD pattern, but not the entire thing, so we'll turn our attention to that today. By way of introduction, I'd just like to refresh your memory on the contents of the CRUD pattern itself. We've got here in the first column, create, retrieve, update, and delete. I'm calling it retrieve instead of read because that's a little bit more descriptive in the context of a database application. And then we know that those operations correspond to the HTTP methods. The create is a post, the retrieval is a get. We have two variants of the update, a put, which is supposed to replace an existing element, and a patch, which is supposed to just update an existing element, and then finally delete. You can see in these last two columns here, I've tried to indicate the connection between the particular method and whether it's a collection or an element. And the patterns that are kind of less common, I've just put a dash here to indicate that you very seldom see those things in practice, but the rest of them are fairly often encountered. For this little example, I'm going to use a very, very simple database schema. You can see I've got a company table here that's got a name, a city, and a state, and then its primary key is this ID value. And then I've got an employee table whose primary key is also called ID, and it's got a first name and a last name and employer, and the employer here is the foreign key that refers to the company. This is the syntax it's sometimes used for relationships. In the syntax that we were using in class would be something more like this. So an employee has one company, but a company has multiple employees. Okay, let's start with the retrieve operation. We're already familiar with this from the exercises we just did recently. In the first case, we'll look at how do we retrieve a collection, and we can see here that the method, of course, is going to be the get method. The path that we're going to use for our endpoint is /companies. Usually that's a plural value because we're getting multiple companies. And then the handler function we're familiar with from the homework exercises where we're using a company object that inherits from the objection model class, and then just executing the query with no additional arguments or method calls on it. So that's just going to fetch all of the columns from all of the rows in the company table, turn those into an array of company objects, and then hand them back to Hapi. And because this is a promise, Hapi will await the promise and return the results that come back from the promise to the client. There's one new thing here in the configuration, literally called config. So all of these properties in this top level object that we're using to configure this particular route handler supply the specifics of what we want this route handler to do. The configuration is kind of providing some metadata for the config. One thing that we can stick in here is a description, and you'll remember that when we use that package called blip, weird name, this guy is what prints out the list of routes that are supported by this particular server. And when it sees that there's a description associated with the route in this config object, it will include this text in that display of the available routes. So it's just kind of a handy documentation tool. The second type of GET request that we can issue is going to include not just the resource name, but a particular resource ID. And remember that this is the syntax that Hapi uses to identify a parameter that can be filled in at runtime. So whatever it is that the client program supplies as the ID for the company to be retrieved will show up inside the route handler as params dot the name of the parameter. So the request object will contain this params object, and that params object will be populated from the param that shows up in the URI. Let's focus on the handler first. The query is quite simple and familiar. We're using the company objection class. We're running the query method on that, which remember gives us back a connects query object. We include a where clause because we're trying to get the particular company that has this identifier. And then we're also using the eager method to pull back the employees associated with that company. So we'll get the company itself by its ID, and then all of the employees that are connected to that company in the database will show up as well. Again, we're returning a promise here. Remember that the query method on the model class gives us back a connects object, and when we evaluate that connects object, we get a promise back. That's what's returned back to Hapi. Hapi sees that it's a promise, it waits for the promise to resolve, and then sends the result of the resolution back to the client. There's a new thing here in the configuration object that's called validate. We'd like to be able to provide some validation for things like this company ID. Remember that although we can assume in most cases that that is going to come from client software that we control, our web application, for example, it's not guaranteed to come from there. There might be a bug in that application. There might be bad guys that are trying to hack into our company using this web interface. So we want to be careful to verify that the contents of this request are what we think they should be. The validate clause allows us to attach information to this route handler that will instruct Hapi to run some code to check to see if various elements of the request conform to certain constraints. We can see here that there's an object inside the validate object called params, and that corresponds to the fact that we're going to be validating something from this params object that's going to be populated by Hapi when it parses the URL. Params is itself an object that has a company ID, so the key in the params object is the field from the params list that we want to validate, and then the value of that property is a function call. Actually, it's a collection of method calls defined on this new object called joy. You remember that I told you that Hapi is kind of inspired by Ren and Stimpy. So happy, happy, joy, joy is a Ren and Stimpy thing. Not important if you're not familiar with them. But joy is another JavaScript package that's built by the same people that build Hapi. And its goal is to provide a capability to do validation. Joy is actually a standalone package that can be used elsewhere. I've seen it used in a number of different contexts outside of Hapi, but it definitely works well inside of Hapi. So on that joy class that we would have imported up above, we can call the number method. And that says basically verify that this value, the company ID property, is in fact a number. However, that number could be a floating point number. What we want to do is make sure that it's an integer because that's what our keys look like. So we can say .integer. And then we also can constrain it to be a non-negative value because we don't have any negative ID value. So we can say .min of 0. And we can also say that it has to be there. It'd certainly be possible for somebody to send a GET request to just the /companies. In this case, we want to ensure that we have the actual company ID that we're going to be looking up and returning to the caller. So this is a first simple example of doing parameter validation. Now notice that because this is something that we're supplying to Hapi, it's going to be responsible for checking to make sure that this particular value in the actual request satisfies the validation constraint implied by this company ID property. If the validation fails, if any of these things that we're saying must be true about that company ID are not true, Hapi won't even call our handler. It will just skip over that part, generate an error message to send back to the client, and our code will never be bothered. So we don't have to do any kind of checking or testing inside of our route handler for these kinds of validation concerns. We let Hapi take care of that, and then we can rest assured that the only time that our handler code is going to get called is if this and any other validation functions pass before we're even invoked. Let's turn our attention to the create functionality. Here's the handler function and the configuration for this endpoint in Hapi. We can see that it's a post method to the company's endpoint, as you'd expect, because we're creating a new instance of this entity. The business end of the function here in the handler function is straightforward. We're using the company model class inherited from objection. We're invoking its query method, which gives us access to the underlying connects object. And then we're invoking the insert statement on that object and supplying it with the payload that we receive from the client. So on the client side, when you pass along a JSON object containing the various fields that need to be inserted into the company, that gets sent along to the server, and Hapi pulls that out and makes it available to us as this payload attribute of the request object. Since that's already an object, we can just go ahead and hand it right to insert, and Connects will generate the appropriate SQL query that will insert that information. We also want to do some validation of the contents of the payload. So here in the validate clause within the config property of the route configuration, we want to make sure that the values that we expect to be there are there and that they have a reasonable format. So as before with the param validation, we can include the various fields that we expect to see in the payload. And notice that we use payload as the key for this part of the validation, whereas we use params from before. So we want to have the name and the city and the state, and you can see that these all are going to be strings. The name and the city are going to have a minimum length of 1 character. It's hard to know how many characters to use as a minimum sometimes, but we want at least 1. And then we're also saying that it's got to be required. I guess these are sort of redundant because if it's at least 1 character long, it's going to be non-empty, which means that the required is satisfied as well. But it doesn't hurt to telegraph our intention that this be a required field. The state value is a little bit different in that instead of saying a minimum length, I'm giving it an absolute length. I'm assuming that these are going to be the 2-letter state abbreviations. And so by saying length of 2, that's going to require exactly 2 characters instead of a minimum of 2 or something like that. Again, if any of these validators fail, the Hapi framework will never even call our handler function. So this won't get invoked at all. We don't have to worry about keeping track of any additional information inside the handler function because Hapi's taken care of it for us. Notice also that we're returning a promise as we did in the previous example because the insert statement itself returns a promise. We're not waiting for it with a .then or anything like that. So that's going to return a promise back to Hapi. Hapi will wait for that promise to resolve itself and then return the resulting object back to the client. If the promise fails to resolve, in other words, if it calls the underlying reject function, Hapi will also deal with that by sending back a 500 message to the client so that it can be made aware of the fact that something went haywire on the host. Okay, we have 2 different ways to update. First of all, we'll look at the put version of this. So this is where we're going to do an update and we're going to actually replace an instance of an object wholesale. So we've got to do 2 things here that are sort of a combination of the ideas that we saw when we were fetching an individual company and when we were creating a company. In the sense that we have to supply both a company ID to say which company are we going to be replacing and a payload that contains the information that we're going to replace in the company that has the ID that we've indicated. So we're going to use a put method. That's the appropriate RESTful API method for replacing something. And we've got a little bit more elaborate validation here going on. Previously, we saw that we could either validate params or we could validate the payload. In this case, we have both a parameter and the payload, so we're going to use both of those types of validators so that we can have multiple key value pairs in here that specify the different parts of the request that we might want to validate. We've seen all of these validation examples before. We can see that we're asking for a required field with a minimum value of 0, and then the same basic content in the payload to ensure that we actually have fields that have something in them before we try to update our database with those values. In the handler function, we can see that we're, again, using the company model class, invoking query on it, and now we're asking connects to use the update method. And as was the case with the insert, we're going to just send along the object that contains all the fields that we want to add over top of the company that we're replacing. We also, of course, want to include a where clause so that we can indicate which company we want to replace. We want to match the ID column of this table. And we're using request.params.companyID again to get the value that was sent in with this request from the client in order to update the right thing. Now, it's a little ambiguous what we return from a put request. With a get, it's pretty obvious, right? You want to either return the single element that you requested by ID, for example, or you want to return all of the elements. In the case of an update, though, I guess there's a couple of different things that sort of come to mind. One would be to return the updated object. So we could update the company and then go and fetch it back out of the database and send it on to the client. What I've done here is a little bit different, just to show you that there's different ways to approach this. In most cases, when you do a update operation or a delete operation on SQL, it tells you not the new values of those rows, but it tells you how many rows of the underlying table were affected. So if I send in a SQL query that updates 10 rows, the value that I'll get back from that will be 10. And that's, in fact, what comes back from the connects update method. You can see here I'm just tracking rows updated as the return value from this query. Notice that here I've reintroduced the async and the await because I want to actually wait for this update to complete on the database. It's then going to give me back the number of rows that it changed, and by awaiting that, I can let the promise resolve successfully to give me access to that return value. And then I'm just turning around and sort of sending it back to the client. I've constructed here a JavaScript object. The key is updated, and then the value is the number of rows that were updated as part of this request. By returning that back to Hapi, Hapi is going to turn that into JSON and send it back with the result. And then on the client side, the client could look at that and determine whether or not what it expected to have happen actually took place. In other words, it updated one row, which is what it was asking for. And if that didn't occur, it could provide some sort of an error message to the user or whatever. There's not really a hard and fast guidance on what an update should return. This is one alternative that you might consider in your project. The patch handler also does an update. We can see that we've got a different method here. Basically the same configuration for validation of the parameters that we're passing in. We're still updating a specific company, and we're going to pass in some payload information that tells us which fields we want to update. Now in this case, though, we're not replacing the company wholesale. In other words, we can update selected fields within the company itself. So one change here is that none of these are required as such. If I leave off the name or the city or the state, Hapi is going to be okay with that. And that's really what I want to have happen here. I don't want to be forced to include all of the possible fields for that company. I'd like to be able to just include the ones that I want to change. So if the company moved from one city to another, we could update just the city and the state, and that would be fine. We want to drop the required there. I left the required alone in this validator, though, because I can't update a company if I don't know which company to update. That has to be there. Somebody has to send the company ID, and I can verify that it's present with this Joy validator. Then the handler function is quite similar to what it was for the previous case, where I'm going to do a similar operation here. I'm going to call update, just like before, and the fact that this request payload is whatever fields get sent in to the endpoint from the client in the JSON payload works exactly the same way. The way that connects is defined, if you don't specify all of the fields in an update, you only are going to generate a SQL query that updates those fields that are present. So that works just fine for our purposes here. I'm also, in this case, waiting for the return value to come back to tell me how many rows were updated, and then I'm creating a JavaScript object that will be converted to JSON in the response back to the client. So very similar kind of approach here. Finally, we need to be able to delete things. Here's our route handler. The method that we're configuring in is delete. We need to know which company we want to delete. We could also have a company's delete that didn't include the specific company ID to delete all the companies, but that's a very unlikely requirement to have because you don't want to just throw away key business data. Configuration now still has a validator that's validating that company ID, exactly the same sequence of method calls on that object, including the required field because we do want to delete just that one thing. I've done a little bit more in the handler function just to illustrate that you can do any kind of processing that you would like inside this function. The business end of it here is this delete method. Again, that's just coming from the company's objection model, pulling out the connects object, and then asking it to do a delete. And of course, we need to have a where method here to specify which of the companies it is that we want to delete. Now, so far, I've pretty much just been finessing the return values from these method calls and passing them back to the client without a whole lot of additional overhead. But it's also possible to do more error handling here inside of the handler. So just to illustrate that really simply, I'm checking to see if the number of rows that were deleted actually is 1, right? I'm specifying a company ID that I want to delete, since that company ID corresponds to the primary key in the company table, there's only one of two possibilities, I guess, in addition to just sort of a complete failure. But either that company exists and it was deleted, in which case the rows deleted here is going to be 1, or it wasn't in the database, and in that case it's going to be 0, which I probably want to let the client know about to say, hey, you asked me to delete this company, but it doesn't exist. If everything works as expected, in other words, if that value is 1, I'm going to return a very similar kind of JavaScript object that will be encoded as JSON for the client to say, here's how many things I deleted. But I'm also going to do some error checking here to say, well, if it wasn't that value, if this if statement tested false, I'm returning now an error object back to the client. You can see here we got this crazy named boom thing. This is another one of these packages that's developed by the Hapi team that works great with Hapi. And its principal job is to just generate error responses that you can send back to the client in a consistent way. So there's a bunch of methods that are defined inside this boom class that create different types of errors that can include a specific string that you can provide to it, and that'll generate a standard HTTP error message and send it back to the client where it can be interpreted. Just a simple example of how we can handle more of the processing on the server side instead of fobbing that all off onto the client. And they'll include a link to some resources here about the Joy validator package. It's got a ton of different sorts of validation of all kinds of things within the JavaScript language. So you can verify objects and arrays and all kinds of stuff. Worth taking a look at least to just familiarize yourself with the space of possible verifications that you can do, and then go back and use that selectively as you have need.